Let's begin with question number 1. Okay, let's move it to whiteboard, please, and we shall begin. All right, let's read and see. So a geometric progression has the first term of 64 and sum to infinity 256. So find the common ratio and the sum of the first 10 terms. Okay, a GP, sometimes denoted as GP, geometric progression, is a progression that looks like this, where say A is the first term, then every other term after that, we multiply it by a common ratio of R. So that means the nth term would be ARn minus 1, which we can readily see in this pattern. Huh? For example, this is n is the first term, second term, third term. So you can see from each of it, this will be the nth term, because if you look at the pattern, like from 3 here means here's 2. It's minus 1 like that. From 2 here means this is minus 1 like that. And all the way. 1 here means there's no R to the power of R. So n here means n minus 1. Ta-da! Okay, that's one thing. So we also notice that in terms of pattern, this is like multiplied by R. Okay, it's just to get the meaning, a common ratio. So R is called the common ratio for GP, whilst A is called the first term. Okay, these are the two parameters we need. So how do you find a common ratio for this? So we read back the information. We see that, they say that the first term is 64. So that means immediately we know that A is 64. Sum to infinity is a special formula. Okay, I'm just going to use the formula straight up. So that means basically S infinity is A over 1 minus R. So this is given as 256. Oh, that means it's just another way of saying we can use this to find R. This A over 256, rewriting 64 over 256, putting it in a calculator. 64 over 256 would be 1 over 4. From which now, if 1 minus R is 1 over 4, we can solve this to see that R is 1 minus 1 over 4. Or we can find the answer for the first part finally, which is R is 3 over 4, the common ratio. Okay, let's go for the second part, please. Okay, so they say the sum of the first 10 terms. Okay, now we need to use the sum formula. Generally, sorry, Sn is equal to A 1 minus R to the power of n over 1 minus R. Okay, it's a number of terms like that. So here in this case, we got the A, 64. We got the R, we just found it, 3 over 4. So I prefer writing it as 0.75, easy to key in on the calculator. And then we also have the n, which is 10. Oh, so that's how, because the n is 10 from here. First 10 terms. Okay, let's substitute and calculate this first. So that means S10 will be 64, 1 minus R to the power of 10, whole thing over 1 minus 0.75. So let's just simplify all this first. So this is 0.25, like that. And then this is 1 minus 0.75 to the power of 10. Okay, so this is just some calculator work. Okay, let's put in the calculator. 64 over 0.25 is 256. Then 256 times in the bracket is 1 minus 0.75 to the power of 10. Is about 242. There's a lot of, what we say, 242, I think. Yep, when we put in the calculator, we estimate it roughly. So it's 3 significant figures without a decimal, you can just estimate it. So the answer would be 242, because for 1.5, we're rounding it. Thank you.